Okay, so for our class today, we will be talking about the interior angle of a polygon. Now first, before we dive into the topic, let's understand what is polygon first. Right. The word poly over here means many. Alright, the word poly over here means many. And the word gon over here, alright, it means it has sides, it has angles, and it has corners. So in another word, when we are talking about polygons, we are referring it to shapes. Okay? So when I said what's a polygon, basically it's referring to a shape with many sides. Like for example, this one, it has 3 sides, so it has many sides. It is a shape with many angles. So in this particular shape, there are a total of 4 angles over here. We can also describe polygons as a shape with many corners. Alright, so we can see over here there are 1, 2, 3, 4, 5 corners over here. So that is basically what a polygon is. But in our topic today, we are interested to know the interior angle of a polygon. So when we are talking about an interior angle, we are referring it to the angle inside the polygon. Specifically, these angles at the corners over here. These are the interior angle. Okay? So over here for this shape, this one, it's the interior angle. Right? The interior angle is always located at the corner of the shape. Now let's start with these two first. So this one is a very basic shape. This is called a triangle. And this one is called a square. Now, we have been dealing with these two shapes a lot of times already. So, by right, you should be able to know what's the total interior angle of these two shapes. So this one, for any triangle, the total interior angle is always 180 degrees. Whereas for a square, or for any quadrilateral for that matter, the total interior angle is always 360 degrees. Now these two are the most basic shapes that most of the students deal with. But what about a shape with 5 sides or a 6 sides? How do we determine, okay, what's the total interior angle of this shape? Okay? Now, when we are dealing with a much more complicated shape than what we used to, we must always go back to the basic, right? So we must always rely back on our most basic shape, and in this case, it will be a triangle. So how will this help me to find the total interior angle? We can use this concept over here. Try to ask yourself this question: how many triangles can you fit inside this shape over here? Now, before I show the triangles over here, let's start with something more basic to this one over here, right? Let's see how many triangles can I fit over here. Now, you might have it in your mind right now. If I were to draw this diagonal line across, I will have 2 triangles in my square, which is 1 and 2 over here. Now, there might be some of you might thought, if I were to draw another diagonal line, I will have more triangles inside, right? But our goal over here is to know the interior angle of the shape. By adding this extra line over here, I am finding the additional angles over here. Now, this angle over here does not contribute to the total angle of an interior angle. So in other words, this angle over, this line over here, it's actually not needed, right? It's not needed. A rule of thumb over here, if you want to draw the number of lines inside the polygons over here, make sure the line does not intersect each other like just now. Okay? Make sure it doesn't intersect. So in this case, we have two triangles over here. And let's look at triangle 1. Let's look at triangle 1. So where are my angles in triangle 1? So I have this angle, and this angle. And what about my angles in triangle 2? It's going to be this angle, and also this angle. Now take a look, where are the colored angles right now? If you notice, all the colored angles are located at the corner of the shape, which is what we are interested to find, which is the total angle of the interior angle, alright? Total interior angle of a polygon. So by right, if I were to add up all these colored angles, I should get the total interior angle of that polygon. So with our understanding of triangle, we already know that the total angle of a triangle is always add up to 180. And since I have two of them, I should multiply by 2, right? So I have 180, that's the total angle of one triangle. And since I have two of them, I multiply by 2, and that's how I get my 360 degree. So I'm going to use this understanding over here to apply for this question right now. So let's see how many triangles that I can draw in this shape without the line intersecting one another. So you can start from any corners you like. So for my example, I will start from the top here. So let's draw some lines to make some triangles. So let's see over here. That's my first triangle. That's my second triangle, and that's my third triangle over here. So in this particular shape over here, and this is called a pentagon. A penta because it has 5 sides, and pentagon. Alright? So let's take a look at triangle 1 first. So where are all my angles in triangle 1? So that's 1 here, 1 here, and 1 here. For my triangle 2, one angle is here, one is over here, and another one is over here. For triangle 3, one of them is here, one of them is here, and one of them is here. Okay? So these are all my corner angles, and if I were to add them all up, I should get the total interior angle of a pentagon. So we already know that one of the triangle, alright, for any triangle, the total angle is always 180. And I have 3 of them, so by right I should multiply by 3, and that should give me 540 degree. Okay? And we can use the similar pattern over here to solve for this one. Okay, so this one is a 6-sided shape, and this is called an hexagon. Alright, so I can use a similar concept over here to find the total interior angle. So by right now, you should see I have a total of 4 triangles. 1, 2, 3, and 4. So the total interior angle of this should be 180 multiplied by 4, and that should give you 720 degrees. Okay? Now, of course, based on this over here, I would like you to pause the video, and I would like you to try to find out a relationship between the number of sides and the number of triangles that you can get. Okay? Find the relationship between the number of sides and the number of triangle. Okay? Because if you notice over here from the triangle towards here, you might notice there is some pattern over here. And because when we observe a pattern, mathematician will tend to utilize the pattern to come out with a certain formula to ease us to find for any interior angle for any polygons over here. Now, assuming you have already done so, I will write down over here, okay? So, total angles, total interior angle for any polygon, regardless of how many sides does it have, is equals to n minus 2 multiplied with 180. So that's the formula over here. Now let's try to understand this formula a bit better. Okay? Now you over here, you might notice that the number of triangle form, it's always the number of sides minus 2. There are 3 sides over here. If you take the 3 sides, you subtract by 2, you will get 1 triangle. Same thing as a square over here, there's 4 sides and you get 2 triangles. So 4 sides, 4 minus 2, you get 2 triangles. 5 sides minus 2, you get 3 triangles. 6 sides, you minus 2, you get 4 triangles. So that's the pattern over here. This minus 2 is a constant over here. So this is the relationship that we can find out, and that's our formula to find the total interior angle for any polygons. So I would like to highlight here a bit more. This n over here refer to the number of sides. Okay? While this part over here, okay, refer to the number of triangle. And since we know that one triangle, it's 180 degree, the total angle is 180 degree, so that's why the number of triangle multiplied with this will give you the total interior angle of that polygon. Okay, so that's how you find the total interior angle of any polygon you like. Now a bonus question for everyone, just to learn to apply this formula. Let's just say you have a polygon with 12 sides. I would like you to use this formula to calculate the interior angle of that polygon. Okay? Try that out and let's see if you are able to apply the formula. Thank you.